You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views and insight into the creative world of technology and the people that make it happen. In this month's episode, we are focusing on railways and rail technology and how one of the world's oldest forms of mass transit is changing the way we think about climate change. We also discuss automation and how the heavy rail industry may one day adopt well-tested technologies used on our metro trains. George Stephenson looms large in the minds of most mechanical engineers when you ask them to think about an engineering icon. Indeed, the earliest history of our institution was born from the steam and motion of those early technological developments of the 1800s. But while George and his like would still recognise the rails and the roar, today's locomotives and the services they provide across continents would be beyond even his wildest dreams. And those early engineers would certainly be unaware of the global impact their technology would eventually have on international economics, environment and society. Today, UK rail is a £20 billion industry, with 881 million of that generated by freight transportation. Stephenson would have been very proud. In 2019, passengers travelled over 3.5 trillion kilometres on the world's railway networks, with 3/4 of rail passenger movements and half of rail freight relying on electricity as its main form of power. And indeed, the International Energy Agency, the IEA, believes that global transport emissions could peak in the 2030s if railways are aggressively expanded, particularly as they are uniquely positioned to take advantage of the rise of renewables in the electricity mix, making rail among the most efficient and lowest emitting modes of transport. But moves to expand rail networks are not without controversy, and the environmental impact of large-scale rail construction projects and the level of disturbance caused by railways due to noise and vibration, air, soil and water pollution and soil erosion continue to provoke serious debate. My guests today are both rail engineers and have spent much of their lives following that permanent way. Malcolm Doble has over 45 years' experience in the industry. He was head of train systems engineering for the London Underground for much of that time, leading the 300-strong rolling stock, signalling, track and power engineering teams who provide engineering services to the Underground. He is also a former IMechE Railway Division Chairman and a current board member, and helps to organise and judge the annual Railway Challenge. Malcolm and I discussed the benefits of automation of rail services, the challenges facing rail engineers in designing safety systems, and what other innovations we might see on the railway in the future. Malcolm, welcome to Impulse to Innovation and thank you for joining us. Now, I mentioned in your introduction that you were head of train systems engineering for London Underground until your retirement in 2014. In that time, you must have been part of some significant changes to rolling stock, track and power services. What was the biggest transformation you were involved in during that time, and what had the most effect on the service or benefit to passengers?
Hi, Helen. It's good to be here. I think the biggest change in all my time was the gradual move from electromechanical equipment to electronic, and then doing things with digital equipment. In the 1960s, when I joined, train was powered by electricity. They still are, but it was converted into the power that motors use through camshafts and resistance controllers. In the next 20 years, that all changed, and now anyone who buys a train will get one with electric motors that are AC powered, and there'd be a variable voltage, variable frequency electronic converter to take the DC power from the conductor rails and turn it into AC that the motors need. Signalling similarly was electromechanical when I started work. There were lots of things controlled by pneumatics. The sequence of signals was controlled by a device that looked not unlike a pianola that would have been used for a player piano. And now that's all electronic, controlled by computers. You can go into a room and you can see stacks of 19-inch rack equipment. You point at something, you say, is that the signaling equipment? No, that's the switch. Is that the signaling equipment? No, that's the comms rack. That must be the signaling equipment. Yes, and it's just a grey box. Nothing going on. But the benefit of all that is that when they're doing these things digitally, they record what they're doing. And if anything goes wrong, or if anyone wants to analyse something, they've got all the data from all the trains that can be analysed by someone who understands what they're doing, which is not me, and find out exactly how the service is run, and from that, find ways of improving it. And that's something I would have died for in my 40s and 50s. And I'm 70 now.
Yeah, I'm guessing that that there's a lot of technology now, a lot of digital technology, which is really having quite a significant impact on the way that the trains operate and are controlled. And being able to analyse that data is really quite valuable.
Absolutely. We've been able to show that capacity can be increased on one line by about 10%. Just by spending a small amount of money on some of the restrictions and some of the layout of the detail of the signalling system, which might cost a couple of £1 million, which is in the order of 1/6 of the cost of a new train.
Yeah.
And yet you've delivered the equivalent of 2 or 3 trains more in service. Now that's really well worth having. And it wouldn't easily have been possible 30 years ago.
Yeah, absolutely. Now, it may surprise some of our listeners to know that the London Tube service has been partially automated since the 1960s. That is something that I wasn't aware of. And of course, outside of London, places like Glasgow have had automated train operations since, I think, the 1980s, with ATOs being very popular in many large cities across the globe. So what are the advantages of having these types of automated trains, Malcolm?
Well, there are 2 key components in driving metro trains. Getting from station to station is the obvious bit. But the other bit is managing the dwell at the station, opening the doors, watching the customers getting on and off, closing the doors and setting off again. So of those 2 variables, the one that the organisation has the most control over is driving from station to station. And however good the drivers are, they don't all drive the same way. And there can be a significant variation in their driving styles. And I'm not going to say any of them are wrong, but they don't all drive the same way. And it would take a huge amount of effort to drive as hard as an ATO train can do. So the automatic train operation can accelerate hard up to line speed, run at line speed, and then brake hard into the next station, which delivers the shortest possible run time, so you can get from end to end of the line quickest, and also allows the next train to get into the station, which means you can have more trains per hour running on the service. So the best performance of the underground with manual driving tends to be around a service of about 27 trains per hour, whereas the current Victoria Line train can run routinely with 36 trains per hour.
Oh, okay.
Which is well worth it from the point of view of capacity.
Yeah, absolutely.
Use an example of somewhere like Brixton, where the trains change directions. They've only got 2 platforms, and yet they've got to get 36 trains an hour turned around there. That means 18 trains on each platform, and that's less than 4 minutes per platform. And bear in mind, in that 4 minutes, the train's got to arrive, passengers get off, next lot of passengers get on, a new driver's got to get in at the other end of the train, and the train's got to depart, and the next train arrive, all in that under 4 minutes.
Right, okay.
And that's a significant undertaking. And even back in the 1960s, when it was only running a much smaller service, it was a very early example of how critical path analysis was used to determine all the actions necessary and timing them to make sure they could get the trains turned around in time.
It's certainly something that I think as a commuter, you don't think about in terms of when you're getting on and off the tube train, how quickly that train has to move and get out of the way for the next one coming in, and all of the things that have to go on in that few minutes or even few seconds that it takes for it to arrive at the platform and unload and load and get back underway. I'll certainly consider it to be a much more important thing in the future, I think, when I'm travelling on the tube.
This is a simple thing where the human beings become important is that there's a person on many of the busier platforms whose job is to keep up a continuous public address announcement, hurrying the customers on and off the trains in order to get the train away quickly. And the staff are encouraged to use their own particular personality to make that announcement seem interesting and amusing to the customers, because that seems to make them go that little bit faster. So one person might, make an announcement a bit like a rapper, and someone else might do it a completely different way.
I think that's a great idea. There's a very nice gentleman on one of the stations on the Northern Line who always makes it very entertaining to get on and off the train. Now, you made the point about using engineering techniques to assess the process of getting on and off the trains, and of course, considerable safety issues have to be overcome when you automate vehicles of this size and scale. What considerations do rail engineers have to take into account when they're designing these automated train systems?
As with most engineering systems, how can it go wrong? And how can it go wrong in a way that's harmful? A fundamental principle of signalling, for example, is to avoid wrong side failures. You don't want to approach a set of points that are facing the wrong way. You don't want trains to pass signals that are at danger. You don't want them to pass a red light. And they use a variety of techniques. In the simple electromechanical days, it was relatively straightforward that if you took the electricity off a relay, you could be reasonably confident that the relay would open and you'd be in a safe condition. But even then, the signal engineer would consider what happened if the relay contacts had welded, or what would happen if the motion had become stuck. And that would lead to a whole set of different design considerations that would make sure that a relay was as deterministic as possible. If you energized it, be confident that it would make. If you de-energized it, be confident it would break. Now, they've taken those sorts of principles as far as they reasonably can into electronic systems. Sometimes you will have two systems checking each other. On the current Victoria line, it has 3 automatic train protection systems on the train, on each end of the train, and 2 out of 3 have to vote for the answer. And if 2 agree, then that's what it will do. Now, that's a similar principle to what happens in a huge number of circuits. But there are other things where you don't have that. You can't have that redundancy. Wheels and axles, you can't have that redundancy. They apply whether it's automatic or not, of course. But you have to have good engineering to design axles that won't break. The fail-safe principles are applied to things. You start with where it's easiest to automate. Driving an underground train from station to station is comparatively easy to automate. And in the background, it's got something checking that it doesn't exceed the speeds and will stop it if it goes too fast or goes beyond the distance that's allowed to be safe, called the movement authority. There are other things that it's much less easy to automate. Checking that a train is clear before closing all the doors is not all that easy to automate. You can make loud noises and then close the doors. You can have announcements and then close all the doors. But strange things happen. People sometimes leave it late to alight from the train, and even the driver is is blinded to that. But the driver will rapidly see someone emerge as the doors are closing and reopen them. Whereas the automated system would only notice that when the doors are closed on someone and the system noticed they hadn't closed fully and they would open them again. So someone would end up trapped. So those systems are less easy to automate and often need extra checks, which makes it more complex and may even slow the railway down. So, for example, the Docklands Light Railway is completely automated, except for checking that the doors are clear before the doors are closed and observing the train as it leaves the platform. Those are still in the hands of the passenger services agent who travels on the train but doesn't drive it.
Yeah.
In fact, on the Docklands Light Railway, the favourite seats are right at the front of the train, so you can see, so the passengers can see where they're going.
Yes, I've been on that train before, and it is good fun at the front. It's interesting, isn't it, how we still require that human machine interface to be able to make sure that the safety mechanisms do in fact do the job that we need them to do.
Yeah, now there are fully automatic metros. They tend to be newer ones, and they tend to be metros where someone can comparatively easily access the train if for some reason it stops between stations. On the London Tube, the newest bit of the Jubilee line has got a walkway down the side of the tunnel. So it's quite difficult to access a train if for some reason it stops. But in Barcelona or Paris, places like that where they put automatic railways in, they always have walkways down the side of the tunnel. So a member of staff can walk down to the train if they need to intervene. But I would say the most critical thing, if you're going to have a fully automatic railway, is reliability. Yes, you deliver all the safety stuff, but the safety stuff is about making sure it doesn't do something stupid. And if it does, everything stops. But actually, on a fully automatic railway, you ideally want things to keep going. So you have to emphasize reliability. You deliver the safety, of course, but you have to have the reliability. I can't quantify that, but probably an order of magnitude better reliability with a fully automatic railway than it would be with a manual one. There are some people that say that by eliminating the human factor, you go some considerable way to achieving that reliability because you avoid members of staff making mistakes. And the odd occasions when I've driven train simulators and things, I know how easy it is to make a mistake when driving even when driving a simulator. And for all of us who drive cars, I'm sure we notice how often we make mistakes when we're driving.
Yeah, definitely. Now, there's growing discussion about moving automation into heavy rail industry, particularly in freight and passenger rail services. And in fact, I was reading recently that Rio Tinto have successfully automated one of their iron ore railways in Australia. So with the worldwide growth in demand for rail services, do you see this as an inevitable direction for the rail industry? And will we one day see high-speed automated passenger trains and freight services on the UK rail network?
It depends on the grade of automation, really. Handling a freight train is quite an art. Unlike a passenger train where you can effectively release the brakes and accelerate full bore, a freight train often has to be handled quite delicately to take up the slack in the couplings before the full tractive effort is applied. And to the best of my knowledge, not being a freight person, that requires a little sensitivity. But the challenge of tomorrow's railway is to provide more and more capacity. And all the reasons I've given for wanting to automate metro railways will increasingly be true of heavy rail. The challenge, though, is to provide all the safety features that exist on the metro. So a fully enclosed metro, thoroughly fenced or underground, is comparatively straightforward. Metros generally aren't very long. But that's a challenge on the mainline railway. But where all the trains on the main line are the same and all running to the same characteristics, automatic train operation, so there'll be a driver at the front of the train, but the driver may not be in control of the train, that might be driven automatically, is something I think that increasingly is coming, particularly on high-speed lines.
Right.
I believe that the trains on HS2, at least on the high-speed section, will be automatically driven. So, that is coming. And HS2 is seeking to have a comparatively frequent service, perhaps one train every 3 minutes or something like that.
Mm.
Freight and mixed traffic railways, I think, is more of a problem. I'm sure it will come, but I think it requires freight to be thought of as something a little different. Even delivering automatic train protection, which is the European train control system with freight, is a challenge because freight trains are usually made up of locomotive and lots and lots and lots of wagons. And the signalling system absolutely needs to know continuously that the train is continuous and there's been no breakage or couplings halfway down the train, say, and half it's been left behind. And there is no electrical signal that goes from one end of the train to a freight train to the other. So they can't directly inform the signalling system that the train is continuous.
Right.
And there is no one way that's been worked out yet to deliver that. So I think that the automation on a mixed traffic heavy rail is a bit more of a challenge.
Yeah.
You're taking me outside my particular expertise, but that's how I see it at the moment, as the outsider looking in.
Yeah. Well, it certainly sounds like there's some challenges to be addressed going forward, but the principles, I suppose, the concept is a sound one. But there's certainly some work for engineers to be doing in the future to try and figure out how they'll do that.
Yes.
Now, I am old enough to remember being absolutely fascinated by the APT, the tilting train that came into service in 1984. I'm showing my age a little bit now. With its active suspension systems, I was absolutely fascinated by the way it sort of swung from side to side. But there have been some significant innovations in both rail and rolling stock even since I was a child. So aside from automated trains, what other technological developments are we going to be seeing on the railway in the future? And will systems like maglev, for example, ever become really commercially viable for mass transit services?
I'm a great fan of steel wheel on steel rail. But that's not to say that maglev won't come one day. There's a long high-speed line in Japan being constructed that aims to deliver speeds in excess of 500 kilometers an hour using maglev principles, where all the magnets are powered by superconducting magnets, which have to be kept at an extremely low temperature. And these magnets are not fitted to the train, they're fitted to the infrastructure. So it's a several 100-mile long continuous magnet cooled to a very low temperature. I find that absolutely boggling myself, but it's been a long-term Japanese project. I think they started work in 2014, and they don't plan to have the line fully completed till the 2040s. So it's a multi-generational project. For an island probably as small as the UK, I think steel wheels and steel rails will continue to work really well. I think the developments we're going to see are going to be in electrical efficiency, making better use of energy generated from the train when the trains are braking, delivering new forms of power conversion from the grid to the overhead so that the single-phase trains don't upset the three-phase grid too much. Because one of the challenges with a train is that the power demand can swing from 300 amps taken from the grid and back to 300 amps put back into the grid at 25,000 volts,
right,
almost in the snap of fingers.
Yeah.
And that really does upset the power generators. There are devices that are increasingly being deployed that make it a bit less sensitive to traction loads. There are some other technologies we need to recapture, I think. One of which is if we're to deliver modal shift from cars onto railways, we've actually got to make travelling by train more comfortable. And we've got to make it easy for older people to get on and off the trains. It's been quite transformational on some of the East Anglian routes. that they've had some trains delivered which have the floor level with the platforms and movable steps or movable ramps so that people in wheelchairs can wheel themselves onto the train. They don't rely on a member of staff to push them on. And this is something that should be extended across the rest of the network. It's challenging because not all the platforms are the same height. There's a standard height that's specified, but the railway's old and been built at a whole variety of different times, and it will take decades to get them all to the same height, even if it's technically feasible. But I think that's a critical thing to make the railway more accessible to everybody. And the other thing, a simple thing, is just make seats comfortable for people. Give people enough leg room, make the seats firm enough and the right shape so that they don't get a numb bottom after travelling for the first half an hour, is one thing that seems to have gone backwards over the last 15 years or so, rather than forwards. So many people do complain about what are called ironing board seats.
Yeah.
But quite recently, the Rail Safety and Standards Board has delivered a method of evaluating the comfort of seats, which can be used to effectively in customer workshops to find out what they like, what they don't like, in a reasonably codified way, which will help suppliers demonstrate compliance. Fingers crossed that will be delivered in the next batch of trains that Avanti West Coast that we both use.
Yes.
Are having delivered.
Well, I look forward to having a nice comfy ride down to London the next time I ever get a chance to travel down there. It would be really nice, and it'd be nice to think that engineers have been looking at the problems of comfort as well as the practicalities of moving the trains from one place to another. Malcolm, thank you ever so much for joining us today on Impulse to Innovation. It has been a real pleasure to hear about not only your experiences and your professional career, but also some of your thoughts on where the rail industry is going to go in the future. So thank you very much for taking the time out today to talk to me.
Absolute pleasure. Thank you very much.
I chatted to retired railway engineer and Rail magazine editor David Shears about the impact of decarbonisation on the UK rail network and how a blend of different energy sources might provide new opportunities for the rail industry. David has worked in rail safety and compliance for much of his career and has managed a number of large-scale construction projects to improve safety and utility management across the rail network. David is an ardent supporter of electrification and is keen to ensure wider society understands the impact the railway has on our environment and our energy consumption. Welcome to Eye, David, and thank you for joining us today. David, you've had a very long and varied career in the UK rail industry, but your focus has been very much on the safety and efficiency of the rail network, hasn't it? Aside from the obvious, why do you feel that this plays such a fundamental part in the role of rail engineers today?
Thanks, Alan. I think that's really quite an interesting question. And looking back, it's interesting to see how far things have advanced and changed. In a few decades ago, safety was a very reactive thing. And we're also quite accepting of the fact that there were maybe a dozen track workers killed each year, and from time to time, passenger fatal accidents that would kill maybe a dozen people every few years. Now things have changed really quite significantly, and we have really a very good safety record. And I think what's behind that is culture. There's a lot more emphasis on looking at underlying causes rather than just blaming people. And from an engineering perspective, there's also a lot more emphasis on systematic risk assessment and taking a system approach. So that's clearly spilled over into engineering philosophies, and it's a really good news story, and it's interesting to see how things have changed.
Absolutely, I think we're much more aware of the need to ensure the safety not just of passengers on trains, but also the rail workers that are in the service as well, and that's something that I'm guessing the industry is very acutely aware of.
Very much so. although there are still sadly problems, and it is a hazardous environment, but it's nothing like what it was. There is a genuine effort to learn from any incident that might have occurred.
Now, I talked in my introduction about the impact climate change was having on the way society uses transportation systems. The rail industry has been doing an awful lot to address its environmental impact for many years, particularly around the issue of decarbonisation. So just to give our listeners a brief understanding, what type of things are they doing? And indeed, what more can the industry do to fully decarbonise?
I think there's a distinction to be made between what we're planning to do and what has actually been done in terms of reducing carbon emissions. There is an awful lot of emphasis on research, demonstrator vehicles, reports, what have you, and there is a very real place for that, because we have to investigate what are the best technologies available and follow that through. But in terms of actually reducing carbon, the railway's actually got quite a good record. But ironically enough, we've got a good record by doing nothing. And if I can explain that, probably the only vehicles that are reducing their carbon in the carbon sector are electric trains. And electric trains are reducing their carbon not because of anything the industry's done, but they're taking advantage of the greening of the grid. So, for example, about 10 years ago, a typical electric passenger train had about half the emissions of a diesel train. Now, 10 years later, they've got a quarter of the emissions of a diesel train. And that's all down to the fact that the grid is getting greener. And that's one of the success stories about Britain's decarbonisation story. So the railways actually decarbonises because it's got electric trains, but as we'll probably talk later, we've not got enough of them. The railway is also a highly efficient form of transport. The rolling resistance of a steel rail on steel wheel on steel rail is what, about a tenth, I think, of a rubber tyre. So it's much more energy efficient, and therefore it's much more carbon efficient.
So it sounds like other industries, particularly other transportation industries, have got a lot to learn from the rail industry in terms of the electrification of the service and those sort of areas. Do you think there's some crossover into some of the other transportation sectors? Do you think?
Well, that's an interesting question. I mean, there is talk of putting up electric wires on motorways for HGVs and such like. Practicality comes into all this, of course. I'm not. I think the concept of an electrified railway is very difficult to translate actually into the road sector, I would suggest. But there must be some transfer. I think in terms of the solutions where it's not cost effective to electrify, there is a huge amount of technology transfer that railways can take from roads, for example, in terms of some of the initiatives that are happening on the roads.
The Network Rail's Traction Decarbonisation Network Strategy, the TDNS, which is a bit of a mouthful, I read in a recent report that if just 10% of the electrification programme recommended by that report was implemented in the UK, it would enable about 70% of rail freight to be fully electrically hauled. Now, surely this is a good thing, David, obviously. Do you think that enough is being done to adopt electrification across the rail network? And also, is government really doing enough to encourage its adoption?
That's an interesting question, and there's quite a few questions in that, which I will answer. In answer to your last question, it depends which government you're talking about. In Scotland, from where I'm speaking, there is a devolved administration, and what's happened in Scotland is that the professionals within Transport Scotland know that electrification is not just the only decarbonisation option for most rail transport, but they also know it's actually a good investment in monetary terms and good for the railways of Scotland in terms of how they can help the people of Scotland. And Transport Scotland have been able to persuade their ministers to spend their scarce funding on a full electrification programme north of the border. The approach in England, unfortunately, is quite different. What seems to have happened is that various ministers have got ideas about hydrogen trains and whatnot. And from some of the statements have shown they don't really fully understand the engineering issues that make electric trains so efficient. And the approach of the Department for Transport seems to be, rather than persuade their ministers of the need for electrification, more to defend the statements that ministers have made. So there is a complete contrast in action between the Scottish and the Westminster governments. And I think that's quite unfortunate. And I think what the rail industry needs to do somehow, and maybe the institution's got a role in this as well, is to educate politicians about some of the basic engineering constraints that make electrification inherently so efficient. If we're going to decarbonise, we've got to stop using petroleum. And the challenge for transport is to wean itself off petroleum, which is a phenomenally efficient way of storing and transporting energy. The only other large-scale energy source is electricity, which can be transmitted long distances over wires, but only to fixed locations. Railways are fortunate in that with fixed current collection systems, that electricity can be used as it's generated and fed straight into the train's traction motors. You cannot really get anything more efficient than that, because any other use of energy in transport vehicles, it's not possible to store electricity as such. It needs to be stored in another form of energy, be it chemical energy in batteries or hydrogen. But all those processes involve inefficiencies. It involves carrying extra weight and extra space. And you have none of that in electric trains. It is inherently much more efficient. But the problem is that it is perceived as old-fashioned technology, and that there might be a better technology available in the future if we just invest in it. And that seems to be the view of the Westminster government.
So it seems that as engineers, we need to really think about communicating the understanding better and making it clear to government what really has to go into this process in order for them to understand more clearly and to act upon that information.
I think that's very right. And it actually needs to be done in a way that is clear and understandable to the intelligent layman. And one has to appreciate, politicians are busy people. They don't need a sort of 60-page report. You really need to be able to present these sort of issues clearly and simply in short documentation. And to be honest, I don't think the industry's done that. I think explaining why is very powerful.
Yes, certainly. I think there's some opportunities there for rail engineers to really communicate and demonstrate the value of this particular subject. And it's certainly a conversation that's going to go on for a very long time. And we probably need another podcast, wouldn't we, David? I think to really discuss it in depth.
You're absolutely right.
You did mention actually there, you just touched on other green alternatives such as hydrogen. The institution published a policy on the future of hydrogen chains, I think back in 2019, which recommended the development and the deployment of hydrogen trains, their fueling and servicing facilities as well. So what would be the benefit of this technology? And are we going to see it supplant electric trains, or will it be more of a blended integration and a mixing of different types of green technologies, do you think, in our future rail service?
Well, just getting back to electrification, the problem with electrification, of course, is it needs an infrastructure, and that infrastructure doesn't come cheap. And so, therefore, there will be services where, frankly, it just doesn't make sense to electrify. And currently, the solution for those services is diesel trains. And in the future, diesel trains will be unacceptable. Currently, hydrogen offers the opportunity to store sufficient compressed hydrogen gas to power a train over, say, a range of 1,000 kilometres. And it's the only technology that's currently available that will give you that sort of distance. So therefore, it is suitable for some services. TD&S, off recollection, consider that's probably about 9% of the currently unelectrified network. So it's part of the solution. It's only a small part of the solution, but nevertheless, it's got potentially a very valuable role to play there. And the other thing that actually needs to be borne in mind is that whilst decarbonisation can only happen with a large-scale electrification programme, that's a programme that's going to take place over a good number of years. So it's one thing to consider the final end game, but the transition before that, there will need to be decarbonisation options put in place before the electrification programme is finished. So that there may well be, in the medium term, the requirement for many more hydrogen vehicles than there are in the long term. So it's certainly got a role. There's no doubt about that.
Yes, it's certainly not going to be a sudden and grand change. It's going to be a gentle step change, shall we say, over time, I think, to get to some of this technology in the future. And it's obviously something that the rail industry is working towards with that in mind, that ultimate green goal.
Yes, that's true. And hydrogen's got a small but important role. Interesting in the rail industry and amongst various commentators, and if you follow this sort of thing on Twitter, hydrogen trains are a bit like Marmite for rail engineers. Either love them or hate them. And sadly, I think one of the reasons why they've got a bad name is the way the government seem to be using them as an excuse not to electrify, because they have been oversold in certain areas, and I think that's unfortunate. You've got to see their role in the overview. And I think the other point that's interesting to note is that as far as hydrogen as a means of transport is concerned, railways is really a very small player. I think the Committee for Climate Change reckon that the amount of hydrogen that will be needed for transport, HGVs, for example, might need 60 times more than on rail. So there's an awful lot of developments in the road sector that railways can take advantage of. For example, there's a hydrogen train being developed in Scotland, and you could say that that's technology transfer from bin lorries, because the hydrogen drivetrain that's going to be used on that train is the same one that's being used to be put on a bin lorry in Glasgow, which is quite an interesting concept, I think.
Yeah, absolutely. Well, it just goes to show, as I alluded earlier, that there's a big crossover, isn't there, between the various transportation systems and that we can learn from using and adapting technology across those different services.
Absolutely. I mean, the hydrogen economy, I think, if we look to a future in 2050, which is a fair way away, but maybe not that long away, when there's no petroleum used for transport, which is huge, then we need an additional energy carrier more than just batteries and electricity distribution. And hydrogen is that. And I suspect that there will be a very large hydrogen economy in the years to come. So we've got to move towards that. And so initiatives such as Glasgow's bin lorries and demonstrator hydrogen trains that are being developing are quite an important step along that road.
Well, I'm looking forward now to seeing the bin lorry powered train emerge. But in all seriousness, actually seeing that technology developed and adapted as a step towards creating a greener transportation system, I think is something that we should all really be looking forward to and working towards as engineers. So that's really good to know. Now, we're all looking very seriously at the way that we travel in the future, especially in light of COVID, and with more efficacy being placed on the green credentials of service providers. What do you think the future of rail transit might look like, both in the UK and more importantly, globally?
I think this whole issue's got to be looked in terms of the long term. Certainly, railways right now are a particularly unenvironmentally friendly form of transport because we're carrying a lot of fresh air around the country and with relatively few passengers. So I dread to think what the carbon emissions per passenger kilometre is right now. But that's just now. In the short to medium term, numbers will certainly be much less than railways were carrying pre-COVID. But in the long term, I suspect that rail will be back up to similar numbers. And one thing that is worth noting is because rail is so much more environmentally friendly, pre-COVID, rail, if you took the total transport against total emissions, rail was 3 times more carbon friendly than cars, 5 times more carbon friendly than planes, and as far as HGVs are concerned, 9 times more carbon efficient. So the implications of that is if you can get modal shift from less carbon-friendly modes onto rail, then rail's carbon savings equivalent to more than rail's total carbon emissions.
Right.
Rail can actually save the country much more than it consumes right now in carbon. And that's quite important. But the downside of that is that because rail carries comparatively little traffic, if you actually doubled or even increased its carrying capacity by just, say, 5% from other modes, you would need to increase rail capacity by, say, 45%.
Yeah.
Which is why it's important that we have things like HS2, for example. So in the long term, I think rail's got a very important part to play in providing both an environmentally friendly form of transport and taking traffic off less carbon-friendly modes. But in the short to medium term, that won't be the case. And it's important to take a long-term view of this.
Yeah, absolutely. Do you think there's much that we can learn from rail systems, international rail systems, in terms of what the UK is doing, or are some of those other countries learning from what we're trying to do here in the UK in terms of decarbonisation and so on?
I think the international comparison is a fascinating one. I was at an online event in Russia where they claimed to have the world's most carbon-friendly freight trains. And I thought, well, you check these things out. So I actually went to the various source documentation and found that was indeed true, because A, they have a lot of electrification, and B, their freight trains are about 6,000 tons. So they've got a lot of load on each particular train.
Yeah.
But whilst I was researching that, I then actually compared that with the UK's record and was actually quite shocked, I suppose, to learn, compared with other railways, UK Rail has got one of the worst carbon records. The reason for that is that we use much more diesel as traction energy than any other railway in the world. I think about 50% of our traction energy is diesel. In Europe, I think the figure's about 25%.
Okay.
And so, not surprisingly, we actually have very high emissions. And you've only got to look at the international figure to show the overwhelming case for electrification as far as decarbonisation is concerned. So I think in terms of learning from others, it's us that can learn more from international rail rather than the other way around.
Well, I know that we have an awful lot of members within the institution who are in the railway division and in the railway industry, and I'm sure that they will be only too keen to share their knowledge and experiences with their colleagues across the world and indeed in the UK. And I'm sure if anybody wants to get in touch, please use our email address, which is podcast@imechE.org. David, thank you ever so much for joining me today. It's been a pleasure to talk to you about this very, very in-depth subject. I know we've had a short time to only just scratch the surface, but I'm sure there's much more that we could have talked about today. But I really do appreciate you taking the time to come onto the podcast today. Thank you very much for joining us.
Thank you, Helen.
That's all for this month. In next month's episode, we will be exploring how we keep our workforce safe and looking at what effect remote working has had on the way we manage and monitor machinery in our factories. We will also be looking at the effect of cyber attacks on remote equipment and how we can protect machines through cybersecurity. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us, podcast@imechE.org. All the information on this episode can be found in the episode notes.